Welcome, everyone, to this episode of Build America, the new podcast that's capturing and sharing the very heartbeat of engineering, design, and construction. I'm your host, Kerry Smith, and listeners and viewers, you are in for a treat today as we talk about a unique subject, mainly geotechnical and geological foundations. And this should be interesting to all of us, I know, because as partakers of the beautiful buildings and historical landmarks and other structures, oftentimes I know we don't think about what's been done beneath the ground to support these structures. And so I'm really looking forward, as I know you all are, to learning from Travis Kassebaum today with Terracon. Travis earned his bachelor's degree in geological engineering from Missouri University of Science and Technology, and also his master's degree there from geotechnical engineering at Missouri S&T. And he's been geotechnical department manager and principal at Terracon for 5 years now. And I should add that Terracon is an employee-owned, 6,000 employee-owned consulting, engineering, and scientific firm. And we're just delighted to have you here with us today, Travis. Welcome to Build America.
Thank you. Appreciate the opportunity.
Oh, absolutely. Well, you were generous enough as we talked prior to filming this episode, recording it, about our topic, which is firm foundations for safe buildings and bridges. And I know that you had volunteered to open with a really sort of a fun historical landmark that many of us have seen, and that's Leaning Tower of Pisa in Pisa, Italy. And I know as a college student, when I toured there, I wondered, did they build it to lean? Did that happen afterwards? What's the scoop on that? And how does that relate to foundational engineering? I'm trying to think back when that was built. I think it was the year 1173 was built as a bell tower. But if you could start by giving us your take on why it leans and if it always did, that would be awesome.
Yeah, definitely. So built in 1173 is when it started, and they had several years of construction for it. And then after a couple of years of construction, they actually paused construction. I'm not exactly sure if it was due to the leaning or other issues, but the tower started to lean about the time they got 2 stories on the building. Essentially, the soils in the area weren't consistent, so there were some variations in the subsurface conditions, and the one side on the tower just started drooping or dropping down. About 100 years later, they actually started construction again.
Oh,
And
wow.
as they got several more stories on, construction ceased. And it was about another 100 years later is when they did the final construction of the bell tower, which every time they started doing more work, the leaning started to increase even faster as that height and the moment, got further and further over. The pauses, the two breaks of the 100 years in between construction is really kind of what saved that building and allowed the soils, the clays to consolidate underneath the building. So had they went ahead and built the entire tower during one construction, it would probably likely would have failed immediately. But because they
Wow.
had that time for consolidation of the soils, it was able to kind of withstand, consolidate, and basically get stronger over time.
Isn't that amazing? Because I was going to think the opposite was, which is why I'm so glad you're on here teaching us today, because I was thinking, oh gosh, today a project delay. We never want those, but that's actually the delays are what saved it and made it more structurally sound.
Yep, definitely.
That's wild. I'm trying to remember too what the percentage of leaning is, and if that, I don't know how to ask that intelligently, Travis, if it continues to lean more with time or if it's just sort of maintained that percentage, that angle.
Yeah, and up to just a few years ago, it's been continuing to lean. Now, I believe it was 1996. I read that correctly. They actually started to do some work to try to correct and preserve the building. And so they're doing some drilling operations and removal of some of the soft soils and replacement with better soils the past several years to actually stop and hopefully eliminate any leaning and future leaning of the building. So where it's currently at, hopefully where it'll stay for the longevity of the structure.
That's great because I'm sure people not only want to look at it, I know back in the dark ages in my college years, I climbed it. So I don't know if people are still accessing it, but certainly that would be a concern to make sure it's structurally sound for people to appreciate it, looking at it and standing on it.
Yeah, absolutely.
Well, that's cool. Well, thank you for jumping into that example. I think I should ask you to take a step back for us and just provide. I know it's a very complex subject, and you do a brilliant job, as we've talked many times, of translating it for us as listeners. But give us an overview, if you could, Travis, of how essential firm foundations are and how much engineering really takes place before structures rise that we see. There's so much, I'm sure, that we don't see and we don't appreciate how essential firm foundation is?
There's firm foundations, kind of the base of any structure, both literally and figuratively. Anything that is supported has to have a good support underneath and the bigger the structure is, the bigger the foundation generally. With engineering, it kind of starts with kind of your site assessment, and different areas of the country, of the state, have different geologic formations underneath. The bedrock varies, the type of soils encountered varies, and these structures that are being developed all over all have different foundations based on what's actually down below the ground. And so if you have a weak foundation, something that's not big enough for the structure it's supporting, you could look potentially encounter failure, catastrophic failure of the structures. The Leaning Tower being one example of, had they built that completely all in one construction period, it would have failed with the shallow foundation that it was being supported on. Buildings and bridges. So structures such as buildings and bridges that are being supported on foundations, we gather the information for those foundations by doing soil borings at the beginning of the project. And that soil data, whether it's soil or rock, and some engineering analysis will tell us what type of foundation is most suitable for the structure, as well as the size of the foundation needed. Undersized foundations can definitely cause failure to the structure down the road. Geotechnical engineering, I guess, as a practice is a little bit unique, as we're not dealing with man-made structures. So every site's a little bit different, and there's lots of variables with no right answer. So there's a lot of interpolation and extrapolation that goes in with geotechnical engineering. And that's where, when we're doing the engineering design, those factors of safety help protect and provide a little bit of conservatism on the design so that there isn't catastrophic failures.
No, you explained that really well. And I love how you said that because I was thinking through the different engineering specialties in civil and metallurgical and mechanical and how you differentiated geotechnical because it really is a mystery of what you're going to find and how it's going to affect what you do next. And I hadn't thought of it that way in terms of the number of unknowns that you face, specifically in what you all do at Terracon.
Absolutely. Yeah, every site's a little bit different. We do lots of work in the same general areas, but there's always those hidden little pieces that we didn't have on the previous site that makes that project a little bit more unique,
Oh,
and
exactly.
trying to figure out how to handle those various challenges on each site.
Great. Now, I wanted to appreciate you being willing to talk about some other examples that have nothing to do with Terracon, with your company, but just are examples that we know from a high profile sense. I know Terracon probably wasn't around to build the Tower of Pisa, assuming that wasn't a Terracon project either. But
Nope.
I know we all realize and have seen I think it was back in 2007 at rush hour on the Interstate 35 bridge in Minneapolis, and just seeing that bridge fail with a lot of cars on it at the time. And again, it had nothing to do with where you are at. But I know that I remember reading the National Transportation Safety Board, of course, came in and eventually determined that it was a design flaw. And I believe it was a thin gusset or a thin steel plate that ties the beams together that ripped along the rivets and just caused that catastrophic collapse. And I wondered, in the years since that horrific 2007 incident, did that impact just design of bridges, or was that kind of a one-off situation in terms of what occurred? And again, I know you're just speaking to it theoretically, but would just appreciate your take on that.
Yeah, so it's more of a structural issue, not geotechnical issue, but in the general sense of design and construction, we're constantly undergoing updates and new codes and new guidelines that we have to adhere to. And engineering kind of works with, hey, this past project, this worked really well. We design and build to that new code. And over time, we try to figure out, how can we build that same way, meet the code, but can we do it faster? Can we do it cheaper, less expensive? And so a lot of times we're within the code trying to construct and build and find ways to do it more efficiently until we hit failure again. And then once we hit that failure again, it's like, okay, stop. Obviously, that's not working. So maybe the code then gets updated, and new changes come out and new guidelines come out. And it's just kind of an ongoing process where we're constantly trying to be better and more efficient and improve with things. And by doing so, there's going to be issues that come up. The other other area within our guidelines and kind of practices is inspections and making sure we have adequate inspections being performed in all aspects of projects. And those inspections kind of help to make sure that we're adhering to the codes and building guidelines. And so there's various samples in the past where issues have come up where those inspections may have helped alleviate some of those potential causes of damage to structures in the past.
Is that, I know it differs with projects, but I'm intrigued by the inspections portion of the work. Is that done at particular junctures of construction, or is it depend on the project? Like I'm wondering, typical project that maybe is 18 months to build, how many inspections of various types would take place on that project and how often?
Yeah, a lot of times there's constant inspections happening. So constant oversight during the construction, by maybe the owner's rep as well as the construction agency's rep, observing, documenting, kind of covering their bases, making sure, hey, everything's been constructed as it was designed. And on the contractor's side, everything's being constructed as designed. And here's my proof by doing so. And then definitely on the geotechnical side, when we're out there doing the grading, we're out there testing compaction of the soil, densification of the soil, testing concrete, testing reinforcement. And so really the entire process should be inspected and tested and ensuring that we have quality stuff going out.
Makes a
One
lot of
bad
sense.
batch of concrete or something during the construction phase can cause issues down the road.
Oh, I'm sure. Well explained. So, how critical is, in terms of building or bridges longevity, how critical is the foundation? That seems like a no-brainer question, maybe, but just how does that play into the life cycle or the lifespan of the building or structure?
Yeah, so every structure has a projected lifespan, how long it's going to be in operation, and that is based on a solid foundation, a foundation that's going to support the structure for longer than that duration, but support it in such a way that it's going to prevent any future movement. So under constructed foundation might allow movement of the structure, causing damage to all the structural elements above. So if you have a bridge, for example, and the bridge is supported on 10 piers for the span of the bridge, and you have one bend of that bridge that settles a little bit, well, now you've got all this extra forces and tension on your structural elements that could cause catastrophic damage, or maybe just reduce the overall lifespan of that structure, causing
That makes
maybe
sense.
damage to concrete, which would open up corrosion to your reinforcement and just kind of escalates from there.
As you were speaking, I thought of another certainly St. Louis centric famous landmark, the Gateway Arch. And I thought that was, I think, completed in the early 60s. And I was wondering if back in the 60s, I'm sure it's a constantly evolving science with all, everything that you're bringing to bear, the resources on your geotechnical work. And I wondered back in the case of the arch, if, my favorite movie is that black and white arch movie you watch in the museum. And they're using pretty much their abacuses and their slide rules and no harnesses. And it's early 60s. I wondered if back then they were thinking of these settling in geotechnical considerations or if it was just more simplistic in how they would approach them, back in the day.
Yeah, so I mean, geotechnical engineering's been around since Terzaghi practiced geotechnical engineering, kind of one of the fathers of geotechnical engineering. And so definitely I think during the construction of the arch, consideration of the different forces and everything being applied to such a unique structure was taken into great consideration, especially given the location of the arch right there near the Mississippi River, downtown St. Louis. Definitely all kinds of challenges associated with that and potential forces being applied to it from the wind, from water, from groundwater, and so on.
Wow. And I bet Terracon, I meant to ask you sort of where you're all working and what your geographical coverage area is in terms of where your projects are. But I bet if you're working in St. Louis or in Denver or wherever your project is, it has to be just markedly different in what you're finding beneath the surface in terms of soil conditions. Maybe you could share a little bit about some of the differences in different parts of the country.
Yeah, definitely. So Terracon does work kind of all over the country and some projects outside of the country, and there's a lot of variability. So a good geotechnical engineer is generally going to be an expert kind of in their region. and we get into another area, a different state where it has very different geologic characteristics. Instead of coming to me for that project, it might be better to call one of my colleagues, different office, to help with that project because those subsurface conditions do vary greatly from one location to the next. Southeast Missouri, Boot Hill area, get into a lot of alluvial soils, deep bedrock, soft soil conditions, liquefaction potential. You're down there close to New Madrid Fault, and so there's lots of potential concerns with liquefaction where when you build it, it may be nice and sturdy ground, but if you don't have the proper foundation for that area, and we do have a seismic event that causes liquefaction of the soil, then all of a sudden, the foundation is sinking down, drastically and could have all kinds of issues. And then alternatively, if you're doing a project somewhere with like a shallow bedrock, central Missouri, southwest Missouri, and you have a design for deep foundations, it would be very challenging to construct that, lots and lots of rock excavation. So properly sized foundation for the area is really going to be critical.
Wow. Explain for us again, and you kind of referred to it in context, but what liquefaction is. If you can dumb down that definition for us a
Yeah,
little
yeah,
bit.
definitely. Liquefaction, essentially, is anytime there's a seismic vibration event, generally like a sandy soil with high groundwater, so increased pore water pressure would increase and basically causes the soil to lose the strength. And if you think about it, if you've ever been to the beach and you go kind of walking on the sand, if you're right there next to the water, it can be nice and firm, but if it gets fully saturated, it loses all its strength and you'll sink down. And so having that correct pore water pressure for the soil is kind of critical for the strength of that soil. You can't build a sandcastle with really, really dry sand. You can't build a sandcastle with completely saturated sand.
Well, what a great definition that we can all relate to. That's for sure. With all the instances of the hurricanes and the tornadoes and the wildfires and all that, does that impact how often the international, I'm not sure if it's the international building code or what codes you guys adhere to as geotechnical engineers, but how often do those come out and do these? It seems like increasing incidences of natural disasters. Do they impact like how often new standards are brought forth?
They definitely do impact it. New codes, we generally follow like the International Building Code, but it's really going to be dependent on the project and the state that that project's being developed in and what code that municipality has adopted. As codes are continually being updated, those natural disasters are taken into account. It wasn't too long ago, and we were doing a seismic retrofit project for a very large federal building that was getting updated for the latest IBC code. And so they're having to go in and doing all kinds of additional structural elements. And part of that was kind of better understanding the soil conditions of the project so that they could design the correct seismic site classification for that seismic retrofit. And so I don't know too much about the wildfires here, like in Missouri, not generally a
Right.
big concern, but I'm sure, out west, there's definitely fire codes that have to be updated, and those codes would be updated for those potential hazards.
Sure, makes a lot of sense. Well, I've been so excited to learn from you today. Travis Kassebaum, Principal and Geotechnical Department Manager with the St. Louis office of Terracon. And so interesting just to learn about things that we as everyday people never see, that you all are hard at work at to make sure that what we do see stands the test of time, literally. And I'm so glad you could join us today. Thank you so much for being with us on Build America.
Yeah, thank you. We'll hopefully talk soon.
That'd be great. I would welcome that. Take care.
Bye bye.